be talking around event sourcing, which is I guess it's an old but new way of building applications. I'll talk about what it is, try to get the concept in your mind, and why you might want to use it for your next project. We've been using it in production for around 4 years now at Superscript, so I'm going to mix in a few stories from the trenches in there. I think it's good to share these sorts of stories, and Lawrence did that as well with his database CPU usage. It's good to share mistakes to help others learn and try to avoid them in the future. And more importantly, that it's okay to make mistakes every now and then. This is our sort of description of the tech within Superscript. We're a B2B insurance company. We've got tech which intelligently places customers' risks with different carriers, and we have the ability to move that risk between carriers as we see fit, so that they get the better deal. In addition to that, we offer the business insurance on a monthly basis, which is something that's not seen too much in the industry, and we're sort of translating that monthly concept to the annual concept, which is a little bit challenging with rounding issues and whatnot. And the insurance industry is quite a rich domain, which is what led us to using this event sourcing architecture in the first place. I've been at Superscript for around 3 years now. The company's around 5 years old. The CEO, Cam, is tech as well, so he actually built the first version of our system. And I've been setting up the tech team and setting the engineering culture with us. And so one of our core values is the developer experience, and I really like to describe that as a low pain tolerance. So if there's like intermittent tests failing, or the tests are slow to run, or deploying is slow, you don't have like dedicated environments to test particular features, we really make that a first-class principle to remove that pain from our day-to-day work. Our tech stack is mainly based around Laravel and Vue, hosted on Heroku and Netlify. So it's sort of avoiding AWS and its complexities, like trying to keep things as simple as possible so we can keep that developer experience up. Event sourcing is more of a generic concept. It's not tied to a particular language or stack, and it's probably more popular in the .NET or Java world, but we're using it in the old school PHP, using the Laravel framework. So yeah, I'll get into what event sourcing is. The best way I've seen it described is it is to data what Git is to code. So for the seasoned engineers out there, updating code on a server used to be like yelling out in the office, "Oh, I'm editing the user's file, don't touch it," and then we would make our changes and upload it. And there was no real version control of our code aside from the odd backup of the server. We think that's crazy today. Like, we've got tools like Git and version control and all these CI and CD tools, and to think of this way of doing things just seems a bit mental. But we're kind of doing this with our databases already. So we might have a simple order table, and we are just issuing an update SQL statement, which is basically overriding a value, and we're losing the transition. We're losing the transition of an object and its life cycle and its history over time. So event sourcing solves this in a rather elegant way. I'm just going to take it back to Git for a sec. So just to remind ourselves on how that works, I'm sure we're all familiar. You start off with a blank repository, and then you layer on commits with diffs, and each commit has a description. It has the diff of the code that's changed. Then it has metadata about who committed that change and when it was done, and the commit hash, and so forth. Event sourcing is pretty much exactly the same, but for your data. So you start off with like a created type event. You've got the type of event that's happening, which is your your commit description. and then you've got the payload of data, which comes with that event, which is sort of like the diff. And then you've got created date and the event number and things like that. So I hope that instills like the concept of what event sourcing is in a very high level way. But you can see already the benefits of Git are automatically applied to the data now. We've got a full version history of our objects as like a first class principle. And we can go back in time. So we could just roll back our events to a particular version and see what our data was at a certain point in time. There's some other Git concepts like branching in the event sourcing world, where you can do like what if scenarios and like inject events lower in the stream and then see what happens in the future. But they're a bit out of scope for today, and they're a bit more advanced topics. So yeah, hopefully that makes sense. Like any tool, you can use it in the wrong way. So I'm not sure if you have commit rules at your work, but occasionally if we're like spiking out a new feature or something, we will do the whip commits and the dot commit and the fix issue and the revert. You can do similar things in event sourcing, like if you were just using very generic event descriptions, like just create, update, delete. It's not really useful. You're not using the power of event sourcing. So I'll get into our first war story. So this happened when I first joined Superscript, roughly. This happened about 2.5 years ago. I was doing some refactoring, changing the events around, and using that feature of replaying events to rebuild our database. But I accidentally left one of the event listeners live and actually charged a fair few of our customers twice for their policies. So that we learned a big lesson there, not to have any side effects when you're replaying events. So keep that in mind if you were to implement this pattern. So I guess there's lots of reasons to use event sourcing. I just want to pull out my two favorite ones. The first one is all around like domain-driven design and capturing the business intent and really modeling what your business is within the software and the code that you write. So just as an example, I touched on previously, we might have an order table that went from pending status to paid, and the outstanding balance went to 0. But we've sort of lost why that had happened. It could have happened from an API call to register a payment, or it could have been a discount that's been applied to the order. Without extra tooling and infrastructure and tables and stuff like that, it makes it hard to just look at the order and see what's happened. So with event sourcing, these events, the state transitions for your objects are treated as like first-class citizens, and so you can easily see the timeline of your domain objects and how it works. And so these events are like stored as structured objects in your code, so you can really model the processes that are happening in your system, rather than like translating that into a post request to a payments endpoint with a particular order ID. You don't lose that through this modeling process. The why number 2. So we've probably all worked in systems which grow in complexity over time, and event sourcing is a great way to split up your domain objects into different concerns. We've probably all built a CMS. It's part of a rite of passage in learning to become an engineer. I know I've done it previously. So just wanted to pull out like the concept, an example of a page object in a CMS. It might just start out with a title field and a content field, and they're the content concerns, and that works well. We've got a blog up and running. It's starting to gain some traffic and popularity, and we want to start adding analytics to our model. So we would naturally go into the database, add some new columns about the number of times that page has been viewed and the average read time, and then we want to start collecting user information. So we'll add some forms and we'll add commenting onto the page, and that page model in your code is starting to grow and grow and grow and grow, and it starts to become a bit unmaintainable. So what event sourcing does is it separates your write concerns from your read concerns, and it really allows you to split up these large domain objects into individual bits and really encapsulate specific events that are going to happen instead of like just chucking it all into the one table. So usually you would have a one way to write to your objects and the different methods that you can do, and then you can have one or more read models which are purpose built for particular things. So this way you can keep your pages table in your database just as title and content, and it doesn't have to worry about all the analytical concerns. And you can set up other areas in your database which only have analytical data, so they're purpose built for that, for reading data, which is really good for scaling in the future. In addition, you could write event listeners which send stuff to Elasticsearch or other analytical platforms to really create those really optimized read models. So this one happened, my next war story happened not too long ago. We did the Ghostbusters thing of crossing the streams, essentially. So we've got two different event streams, and they both went into the one database in production, and then further events were raised from this mixing of streams. So there were IDs mixed between environments, so that was a bit of a pickle to sort out. It was sort of like separating sand from dirt, but we got there in the end, and we had some data tests to verify that. So I guess this is more of a no-brainer to not mix your environment configs in the future, especially as your infrastructure gets a bit more complicated as the business and the system grows. Just one last thing. If I've confused you in any way, or you think that having all these different database tables and the read and write concerns are separated, I just wanted to highlight that these concepts sort of exist already in right across the stack. So in the front end, we've got Redux for React and Vuex for Vue, where you sort of commit mutations, which are like the events, and then the read model is the state, which is what your component is rendering to the browser. GraphQL is clearly separated between mutations and queries. REST APIs have the post, patch, and delete as to deal with your write concerns, and the get method is meant for your read concerns. And even databases, which have been around for decades, you might store your core model data in simple tables, but your read model might be these really complex SQL queries, which you might create as views or materialized views. So it's and I think my takeaway from this is that this stuff has existed at a technical infrastructure level all this time, but what event sourcing does, it really raises it to the surface so that this write and read business concept is raised to the software design or the business level, rather than being a technical implementation concern. So yeah, that's sort of it in a nutshell. So I hope I've distilled the concept of event sourcing and why you would use it in your next project. There's tons of material out there on the internet if you want to get involved, and if you want some pointers, feel free to get in touch, and I can share my learning journey as well.